Hey, we are on. Hello. Gee, that was quick. B. Graziani, how 23, how are you? You're the wow, that was quick. Um, Nice to have someone chime in. Okay, you know the drill. Mic check, video check. Audio, video check. Check, check, 1, 2. How do we sound? How do we look? We got lighting. Are we loud and clear? This is the most important job of anyone who's on the chat first. Okay, sound good, look good, check, check, good, good, good. All right, this is good. Hey, guacamole, hello. Okay, hey, Anto. So we got guacamole. I've never seen WSG before, but I figured out what it means. My lizard brain has always think about the WSG as WSB or Wall Street bets on Reddit, and you know, that's let's say that's quite an interesting place to be. I know this is being recorded right now, so I gotta be very careful what I say. Hey, Anto5710, how are you? How are you? All right. So we're good, and today I am going to need text editor. Got a web browser. We're gonna use a terminal quite a bit. Yes, yes, yes. I know we're got like 1 minute, so I'll just do my introduction now, and then at 4:30, I'm just gonna get right to the gist of today. So I just want to say thank you all for tuning in. Yes, this is the second episode of season number 12. Yes. Hello, KBY4. KBY4. How are you? Yes. Hello. Thank you everyone for tuning in. So I'm Ming Chow, I'm teaching professor at Tufts. Yeah, this is Introduction to Security. This is the second episode, season 12. And the gist of today is spyworks. Yeah. So here's the deal. If you're trying to attack anything, computer system, if you're actually in physical warfare, you don't want to go guns a-blazing. You don't want to do that. If you're going to be building a computer program, you need a plan. If you're going to be building a house, you need a blueprint. You just can't hack shit up. You just can't do that. And I see a lot of people try to do that, when anything, especially when you're trying to target or attack systems. And it never works well. So, the first thing I want to show you is this concept better known as the cyber kill chain. The cyber kill chain is a very well-known concept that was developed by Lockheed Martin. So a lot of terms and concepts in cybersecurity basically are derived from military concepts. Now, the cyber kill chain, what it is a framework. It's a framework that can be used for both good and for bad. This is basically a model for how attackers and adversaries work to complete their objective, namely a bad objective. But the same, mindset and the same model that adversaries use is very, very important for defenders and for the good people to actually understand. So here's the cyber kill chain is 7 steps. 7 steps in understanding how an adversary works. Step number 1 is the most important one. It's reconnaissance or recon. Harvest email, conference information, etc. Number 2 is weaponization, which is to build the exploit, backdoor. Delivery is step number 3 is, the phishing, the USB stick, going to a malicious website. 4 is the exploitation, to execute the code, to execute that weaponized bundle. 5 is to install malware. 6 is command and control to manipulate your target once you have actually gotten access. And then number 7 is hands-on keyboard, accomplish goals. In this course, we're going to cover reconnaissance, weaponization, delivery, and exploitation. We're going to see that throughout this entire course. I'm not going to get so much with CNC. That will be usually reserved for a malware course. But today, by far and away, the most important topic that we're going to cover, we're going to do number 1, reconnaissance. Reconnaissance is information gathering. Now, information gathering is, you can think of it as, it goes by many terms, stalking, spy. And there are many ways that you can do reconnaissance, both high-tech and low-tech. So, a low-tech way to do reconnaissance, and this is still a thing, just want to let you know this is still a day-to-day thing, is have anyone ever gone to like a bank or a store or that has been going out of business? Good examples are like a GameStop or a bank. Like, if you actually know of one of those places that are going out of business, one of the things that you really should try to do, is going to be really cool, is go to the dumpsters and just rummage through the dumpsters and see what you can find. Historically speaking, when banks go out of business, they just dump all like bank records that contain like social security numbers in the bank's dumpster, not even shredded. A lot of people have said that when GameStops go out of business, they go to the dumpster and they find like unopened boxes of they find like boxes of game toys, used controllers. Yeah, it's like you get. Hey, Quantum Cork and Woho Army. Yeah, it's like you get to know so much from someone's trash. These days, that still exists. That stuff still exists. The other thing is, if you're going to be doing high tech, if you're going to go like high tech reconnaissance, social media, huge. LinkedIn, goldmine. There's so many tools that you can use for high tech reconnaissance these days that you can just go crazy on it. So we're going to do reconnaissance today, primarily information gathering. And we're going to actually look at not one, but we're going to look at 2 targets. Target 1. Target 1 is only available on my home network. At home, not available to you folks. And the reason why I like to use target number 1 is because it's fast. I don't have to go to the internet to get information. So target number 1 is 192.168.1.18 on my home network. Again, this is not available to everyone in the world, only to me. But this is a really good example. Target number 2. This one is available to the world. Target number 2 will have the IP address of 3.12.160.152. So we have 2 targets here. Two targets here. One local, one that is on the public-facing internet. So my first question is, like, what kind of, these are 2 targets. What kind of information do you want to get? We have 2 targets here. What kind of information do you want to get? And we're just going to list them out. Go. Like, you're going to be attacking these 2 systems. What kind of information do you want to gather about these 2 targets? Go on. Speak. Go. Ooh, open ports. Okay. Open ports. Ooh, Fred said open ports. 77 Emo said open. Ooh, I like that one. Operating system. Yeah. Location. AKA physical location. Really is physical location. That's what B. Graziani said. Alright, what else? Come on. Device type. You can also do device type as well. I like that one. Connected devices. Okay? I like that one. What else? There's a couple of other things that you can say. Connected devices. Ooh. What else? Anyone? Chime in. Hello? Anyone? We got connected devices. Login info. Like that one. What else? You know what? You said someone said operating. Whoever said, I mean, we have 77 emails at operating system. Why don't you say software version? Software version. Login info. Packets. I like guacamole. I like guacamole. One. Guacamole Winkle Pie says webcam. I'm putting that down. I'm putting that one down. You know what? I'm saving this document. I'm saving this document to call recon.md. Oh, yes. Yeah, I'm going to put, administrators. I'm going to say one more thing and then we can call it a day. Are these targets even real? Like, is the target even up and running? Like, you don't want to be, scanning or trying to get information on a target that doesn't exist. Yeah, it's like, it's like, no, you want to make sure that you want to see if the target is even up and running or not. Okay. Oh, yes. So some of you folks may actually have seen that second one, but there's something else I added on there. The Woho Army is, that IP address for target number 2 may look eerily familiar because it is. It is, but I've added something to it. Okay? So, alright, so now let's do this. The next thing that we're going to do is we're going to answer, let's say the next step is, okay, we have 2 targets here. Let's gather today on Twitch. We're going to get open ports. We'll do that. Operating system, we'll do that. Location, we can kind of get that today. Device type, absolutely. Connected devices, maybe. Login info, maybe. Software being run, absolutely. Packets, yeah, we can do that. Webcam and pics, ooh, well, that's definitely for next Tuesday. Administrators, yeah, we may get that one. And the target, is the target even up and running? Yeah, let's start with that one first. So, the first thing that we want to do is, now we have 2 targets here. The first thing is, are they even up and running? And the first tool that we're going to run and we're going to use is something that is built into all computers, and we're going to talk more about this next week because it can be abused. It's something called ping, P-I-N-G. Man ping. Ping. What ping is think of submarines. So how do sonars and submarines actually work? Okay, does anyone, roughly speaking, how does sonars and submarines actually work? So here is the man page for ping. Sends what is called an ICMP echo request. The fuck? To network host. Anyone? What is ping? I mean, how does how does submarine radars and sonars actually work, roughly speaking. How does it work? Sound, okay, the calibration error says it. Send a sound wave and wait for an echo to come back. So if you're in a submarine and you're trying to you're trying to see if there's an object in front of you, you send a sound wave and wait for an echo to come back. If there's an echo that comes back, that means there's something ahead of you. If you don't see an echo, if you don't actually get an echo back, then there's nothing ahead. Okay? So that is exactly how a sonar works in a submarine, what calibration error said. It's the same exact way that ping works. Okay? The proper name of ping is better known as the Internet Control Message Protocol. The Internet Control Message Protocol. It is layer 3 on the OSI model. Layer 3. What it does, it's a very simple protocol that only uses source and destination IP addresses. It's really used for ping is built into almost every single system in the world, including Windows and Macs. It's used for debugging purposes. Okay, it's used for debugging purposes. Now I repeat, ping is ICMP. People call this ping. Um, The Internet Control Message Protocol is layer 3 on the OSI model. Okay? And this is important to know because it has no concept of ports. So how you use ping is the following. Ping, I'm going to use, what's the first target that we got? 192.168.1.18. If you want to see if a computer is up and running on a network, it's just ping 192.168.1.18. And it's going to act like a submarine sonar. Just going to send an echo and just get a reply back. And here we are getting replies back. 5, 6, 7, 8, 9, 10 replies. Hit the control C, there it is. So 192.168.1.18, I send a ping, I get a pong back. How many pings that got sent out? 1 ping, 2 pings, 3 ping, 10 pings, get back 10 pongs. If you really want to see how this works under the hood, it's really cool. Fire up Wireshark. Okay, if you fire up Wireshark, and now I'm on hardwire. I'm on a hardwire Ethernet because I'm streaming today. Because streaming, you really want to use hardwire. Double click on EN6. That is my network interface for the Ethernet, the hardwire. Double click on it, and whoa, here we go. This is everything that you're seeing between my computer and this is a Twitch stream. Interestingly enough, Twitch uses TCP for the protocol. But what I can do is I can actually filter out. There's a lot of crap that's going on right now in Wireshark. There's a lot of stuff that's going on. This is everything between my computer. So I'm on my local network at 192.168.1.219. I'm just gonna set 35. Hey, while we're here, do a whois of 35 dot 55.30.214. Just curious. 30.14. And yeah, I want to do that. I want to allow whois. Let's do it again. And that's AWS. And that makes sense because Twitch is owned by AWS now. Okay. So I'm using Amazon. Okay. So at any rate, I want to clear the screen. Now I want to actually resume. Just want to continue without saving. But now I just want to filter out by protocol, only ICMP. So now I'm going to do this again. I'm just going to do ping 192.168.1.18. Watch what happens on the Wireshark screen. 3, 4, 5, Control C. And you can see my computer is sending, how ping works is, this is my ping from 192.168.1.219. That's my computer that I'm on. The destination is 192.168.1.18. Ping sends what is called a request, and then, you know, if the target 192.168.1.18 wants to respond to it, it'll send a reply. Reply. 192.168.1.18 sends a reply back to my computer, and which is this one right here. And it does it 10 times. So, well, it does it 10 times overall, but you see there is 5 results here on the ping screen, on the ping, starting at index 0. So there must be 5 times 2 ICMP packets. A set of request and reply. There you go. How it works under the hood. So that's nice, but if you take a look at if you drill down on the details of a ping packet, you will see layer 2 OSI model, the MAC address. Each packet will have a source and destination MAC address. So yeah, I am on a Dell as a source? Really? Now you may be wondering, my destination is a Proxmox server and the source is a Dell. Yes, my Ethernet, I'm using a hub on my monitor. I use a Dell monitor. Now you know. So that totally makes sense. And here's IPv4, Internet Protocol version 4. You can see just the source and destination address. But there's no TCP or UDP. There's no transmission protocol. There's no ping. There's no port. And that's correct. Because, again, ICMP is only layer 3, not layer 4. So you can't, this whole idea of ports, not existent. You can't do anything with ports using ping. In other words, you cannot ping a port. Okay? There's no way you can ping a port. What ping is only good for is to check if a computer is up or running or not. Ping does have its value. It also has been used for abuse years for years. I'll give you an example. What if we actually do ping at this IP address? Ping 3.12.160.152. What the hell? Why? But that IP address, it should be up and running, right? That's correct. Here's the thing, and this will be a topic of conversation next week. Lots of computer systems now turn off the ability to send replies to ping requests. Again, a lot of systems now turn off replying to ping requests. Why is that? Because for years, ping has been abused badly. This is done. That doesn't mean, that 3.12.160.152 is a dead machine. It is very much alive. Ping of death is one. It also has been used for distributed denial of service attacks, 7.7 emo. Now you know. Okay. Can we actually get more physical location of targets? Well, the answer is yes. One way to do it, okay, is if you use Whois. Whois is an internet domain and network number directory service. Whois is a gold mine for human readable information and contact information. It gives you a lot of data, almost TMI. So Whois, and some of you have actually seen this, have used this for the first lab. It's just Whois IP address, and you get a lot of data. So the target number 2 at 3.12.160.152, you can see in the network range of 3.0.0.0 to 3.127.255.255, any IP address that is in this range, the IP address here that I provided, 3.12.160.152, is in that range, all belong to Amazon Technologies, AWS. Here's the headquarter information of AWS. This is actually how you can file abuse reports. and how you can apply, how you file a abuse report, and contact information, and telephone numbers. This is all important information for doing any sort of reconnaissance. Whois is a great reconnaissance tool for like telephone for contact information and even physical information. So I would say location is somewhat done, but there's actually other ways to do this. Yeah, it's for Amazon. Yep. Mm-hmm. Yep, it is for Amazon. Who was it yesterday that had the big layoff? If anyone here is actually working at Amazon and been affected, well, you need a resume review. Yeah, let me know. On another Discord that I'm on, we're getting hit up. We're getting hit up for jobs. Okay, so now the big one that was said earlier is what about things like operating system, open ports, device types, software being run? One, two, three, and four. Yo, it's me. So how does Whois get your name and number when people do that? Yeah. How does Whois work? How does Whois work? Whois really is a lot of contact information that gets when you register IP addresses and domain names. You have to fill out contact information. And that contact information gets sent up, I believe is sent up to a place like for ICANN. Um, so it's like when you register any domain, like any domain name, if you go to like for example go to namecheap.com, and I want to start with guacam. I want guacamole twinklepie.com. I'm gonna hit this in. I'm gonna see if this is available. Yeah, it's $11.28 per year. Um, guacamole twinklepie.com is available. So if you want to actually set that up, then you have to add to your cart, and you gotta pay like a little bit of taxes and stuff. But before you actually register the domain, you have to enter in your contact information, such as your name, physical address, phone number, telephone numbers, and then all that information gets sent to ICANN. Okay, so if I go to cs116.org, which is what I own, I made my shit private, so it's like, yeah, the server redacted that information. But you pay, I think it's free for if you register a domain on Namecheap. But there is an option where you can turn off the privacy, and then if anyone ever do a Whois lookup on your domain, you can get like your contact information. So if you make a website, would you want to put in a different info to maintain anonymity? There is an option for the provider, in this case Namecheap, to actually make it private. Yeah, to make it private. That's what I do. It's like when you have a telephone number, do you want to list it in a telephone book? You have that option to make it publicly available or privately available. I don't know if you remember Yellow Pages, like, to look up telephone numbers for people down the street. This was back in like days when people used like landline telephone, but the same idea for domain names like this. If you go to like Namecheap, and there's so many different domain name registrants out there that you can use. But yeah, if you go to like Amazon.com, now you get lots of information. Like for companies, the game is a little bit different. I'm gonna copy this information. I'm just gonna punch in the IP address. You roughly get similar information online. Yeah, trust and safety, the knock, administrative, list goes on. Okay, so yeah, we can get some physical information on here. Fake information, but one thing I want to let you know, if you want to put in different info, people do that more often than not. Guacamole. I'll just leave it at that. Okay, open ports. What can we do? Open ports. Okay. All right. 192. Let's start off with 192.168.1.18. Give me a port number. Yeah, factory pigeon. You have to go to whoever you registered your domain name in, and yeah, there should be an option to make it private. Yeah. Give me a port number. Throw me a port number. I don't care. 22. All right. So, folks, here we go. How do we actually check for port numbers? I'm going to introduce you to one of the most famous tools around called Netcat. Netcat. Obviously, usually my friend Hobbit actually wrote this. Yes, he's a friend. NC is the command. The Swiss Army knife. Netcat is the Swiss Army knife of the internet. You can do anything TCP or UDP related. Anything. Reading, writing, TCP connections. Okay? You can even do port scanning and file transfer with Netcat. And I want to share with you a cheat sheet from the SANS Institute. Okay. We got 22.255.65. Give me another port number. Okay. So how Netcat works is this. I'm going to blow this up. Oh, shit. Come on, man. Netcat, at the most fundamental, 2 letters, NC, the target IP address, and the port number. And what this does, it just connects to an arbitrary port number at IP address at the target IP at the IP address. That's all it does. And is it handy? You bet it is. You bet it is. I'm gonna clear the screen right now. I'm gonna do NC 192.168.1.18. I'm gonna try 22. No here. I'm gonna hit the enter key. And let's see if we get anything back. Ooh. We got something back. Not bad. We got a response back. Right, just like that. SSH. It's open. Alright, let's do NC 192.168.1.18. 25565. Hit the enter key. Quits immediately. Nada. Give me another port number. Hurry up. Another one. Give me another service number. Give me a famous one. Yeah, we're looking for 80. Let's go. 67. Nope. 443. All right, let's do the other one. Let's do the other target. Let's do the same exact the monkey business. Yuck. 80. I have something. Okay. So you can do the monkey business of 3306. Yeah, let's do that one. Yeah. 21. Okay, we can keep doing this. It makes, it kind of like just keep on entering port numbers. But there is a way in Netcat to do what is called a port scanner. Here. Port scan, TCP port scanner. Port scan and IP address. NC, I'll just do it out here. Minus lowercase v, verbose mode, minus case n. Not resolving domain name, minus z, minus w1. W1 is waiting no more than 1 second for a connection to occur. Target IP address is 192.168.1.18. You have to go to a start port and an end port. So let's do 10 to 1,000. Do it. So this is better than doing a million monkey approach. Oh. But it's slow as hell. Ooh, 22 is successful. But this takes a fuckload long time. Slow. It's like sequential. Oh, it's gonna take forever. Oh, is there anything that's faster? And I can do way more port numbers than this. If it doesn't hit 80, then we're no. What about this? Well, let's go to the other. Go to the other target. Oh, this one blows. This one's not good. What the hell? Alright. Yeah, just email me the link, GUI. Alright, well, here's the thing about Netcat. You can use Netcat, GUI, send me, no, don't drop me a link, just email me the link, because drop doesn't work on Twitch. Okay, so here's the deal. Netcat is nice if you actually just want to test out one particular port. But for port scanning, this is like janky at best. Okay, janky at best. So Netcat works, but is there anything better than this? And a few of you, Cyber.Katrina and Woho Army, and yeah, Netcat is single threaded. It's like, it works. But yeah, it's single threaded. It's really not for port scanning. You can do it. Okay? You can do it. By the way, will you be using Netcat for this course and for the lab? You sure will. Oh yeah. Netcat is great if you want to investigate like what a port is, like a real weird port is doing. We'll do one later. But for port scanning, nah. So now, since a few of you, have said this, let's go to this is one of the tools I install on any computer when I create one brand new. The tool that you really want to use to do port scanning and for network reconnaissance is the network mapper. The network mapper, better known as the Nmap. Nmap was written by my friend Fyodor. Yeah, Gordon Leon. I want to give a shout out to Gordon. The Wikipedia entry for Nmap. The port scanner written by Gordon Leon. It's, written in C++, written in C++, fast, and famous as well. Nmap.org is the website. Here it is. The Network Mapper, free and open source and also platform independent for network discovery and security auditing. Like any security tool, it can be used for both good and bad. System administrators have used Nmap for years to detect like odd stuff on computer networks. So for years, what we had for system administrators would do was use Nmap to actually see what computers on the Tufts network was illegally sharing movies and songs. Okay, so that is a good use of Nmap. Bad use of Nmap is get all the information. Well, that's also hard to say which is bad as well because people use Nmap as usually the first thing to do when they do network reconnaissance. Nmap is free, open source, platform independent. It's also very famous as well too. So here's some movies that Nmap has been in. Let's see, Matrix Reloaded, Ocean 8, Snowden, Dread, Asylum, Fantastic Four, Who Am I, Born Ultimatum, Die Hard 4, Die Hard is a Christmas movie, sorry and not sorry, The Girl with the Dragon Tattoo, G.I. Joe, The Listening, Justice League, Abduction, Extracted, Games of Death, Broken Saints, Casino Royale, no, Battle Royale, not Casino Royale, Broken Saints, don't know what this is, Cotterbotch, Hacksaw, Bloody Monday. Very, very, very. No. No, we've been in the security community for years. Yeah, we're on the same mailing list. And yes, I have met him a few times in person. Okay. Here we are. How do you download Nmap? Gotta download, pick for your system. If you're on Windows land, I would definitely recommend you to use Nmap, the one with the graphical user interface. Definitely use this. If you're on Mac OS land and I have Homebrew installed, you can do brew install Nmap. I already have it installed. Man Nmap. If you do the manual page from Nmap, yes there is, it's long and it's gory and it's glorious. Nmap is a network exploration tool of insecurity and port scanner. It's designed to rapidly scan large networks. You can even use it for single hosts. Using Nmap is really simple. At the most rudimentary level, it's really simple. There are also other stuff that you can do. There are so many options that you can do with Nmap. So how do you use Nmap? You have it installed. All you have to do is, at the most rudimentary level, Nmap, the IP address, hit the enter key, bang. That's all you have to do. And you wait. And wait. Sometimes it takes seconds. Sometimes it takes minutes. So we know that port 22 should be open on 192.168.1.18. We know that. I mean, you've seen it from Netcat. Can you run multiple Nmap scans at the same time? Yeah, that could suck. You shouldn't. You can do it, but you shouldn't. You know what? Since this is actually scanning my local network, I'm going to take liberties. I'm going to run another Nmap scan, but on a different target. That 3.12.160.152. Jesus Christ. Come on, come on, come on, come on. It's working. I can start. I'm actually having continue without saving. And you can see, like, there's just so much crap happening now. Holy cow. Actually, I'll need, I actually can use Wireshark in a bit. Ah, here we go. Geez, that took a long time. Here we go. The Nmap result for 192.168.1.18. Here we go. It took 78 seconds. 78.62 seconds. One IP address is up, one host up. Hey, I also got this one as well, too. One IP address is up, scanned in 43.89 seconds. Why is one faster than the other? I have no fucking clue. I have no idea. Host is, the latency is 0.0. Okay, that's weird. So, let's take a look at 192.168.1.18 first. Not shown 998 closed TCP port connection refused. Found 2 open ports. 22 and 5000. Now, here's how you read an Nmap result. 3 columns. The port number, that's obvious, and got the port number and the protocol, the state, and the service. That's how you that's like on a basic Nmap result. It's the port, the state, and the service. The good news is that the state with both 22 and 5000 are both open. So, what the hell is port 5000? So we know that port 22 is SSH. But I can do netcat 192.168.1.18, and I can type in 5000. You can do T4 to be a little bit quicker, yeah, but what the hell? Hey, what the hell, man? Interesting. Well, something is there. One thing you can always try, although this isn't shouldn't be dead accurate, just go to like a web browser and just type in the IP address colon the port number. Oh, there's something there. Yeah, there's something there. And I got a site. Not bad. So I got a site there. Why is it not firing up something? I don't know. So that's another way that you can try to see if there's something there. But Netcat should have actually brought back something here. Yeah, I don't know why it was not finagling. Okay. So now we actually know on 192.168 there really is something at 5000. Here you go. A whole bunch of financial news. Okay, we'll do the minus A1 next. We'll do the minus A1 next. We'll do that and minus T4. How about this one? 192, this is the 3.12.160.152. We have not 1, not 2, not 3, but we have 4 ports listed. But 3 of them are open, 1 is closed. And you can see the services. Okay, so in this case, we know that the open ports are 22, that's SSH, we all know that. Port 80 is HTTP. 443 is closed, or there's no HTTPS. And we have, what the hell is 3000? This is where you can try, let's do this again. Okay, that looks like, just type in some random garbage. So it looks like it's some sort of an HTTP site as well. So now you know that this 3.12.160.152 has opened port 80 which is HTTP. So what you can do on a web browser now is you go to http:// the IP address, hit the enter key. You don't even need 80 because by default HTTP is 80 and you'll get this website. That's what's there. Now, what happened if I go to https:// 3.12.160.152? Well, HTTPS said it's closed. This shouldn't work. Doesn't work. Doesn't work behind. Not at all. Wait a minute. What about that port 3000 thing? Yeah, just go to http:// 3.12.160.152:3000 and you have not Uber. What the hell? I have an Uber clone here? Maybe. Okay, so what we want to do first is to understand how the hell you read this thing. How do you read this thing is the port number, the state, and the service. The most important thing to understand is the state. Let's read that. Okay, there are 6 states by Nmap. There's open. Open is what you're looking for. Open means an application is like SSH or HTTP is actively accepting connections. Finding these is often the primary goal of port scanning. Security-minded people know that each open port is an avenue for attack. Your goal is to find open ports. Okay? This is your goal. Closed ports. Closed port means it's accessible, but there's no application listening in onto it. They may be helpful because one day it may open up. But really, if you see closed ports, move on. But keep it in the back of your mind because sometimes the closed port do open up down the road. But you want to keep it in mind. There's also a filtered option. Filtered state means an Nmap cannot determine whether this port is open because some packet filtering is preventing probes from reaching the port. Okay, so this is one of those that you want to keep in the back of your mind as well. The unfiltered state means the port is accessible, but Nmap can't tell if it's open or closed. Okay, open or filtered means Nmap think, I can't tell if this port is open or closed, or open or filtered. Okay, closed filtered means unable to, is unable to check whether it's closed or not. Really, your goal is the most important ones to know are open and closed. Okay, if it's closed, yeah, the port exists, but there's nothing behind it. A good example is 443. 443 is closed. There's not, there's no HTTPS. Later today, I may open up HTTPS. Maybe. Okay? Maybe. So, yeah, you want to be looking for open. Open is what you're looking for. So that's number one. So how does Nmap actually work under the hood? How Nmap actually works under the hood. Now, do you folks remember the TCP three-way handshake? Sync, ACK, and ACK? Okay. Port scanning techniques. This is a really, oh, you know what? My bad. I should post port scanning basics. And this one, the port scanning techniques. Port scanning techniques, this one's a good guide. Because really, this is really good first paragraph is automotive repair. You really, there are different tools for different situations. Okay? There are dozens of different types of scan techniques. Some are more appropriate for certain cases than others. Inexperienced users and script kiddies try to solve every problem using the default sync scan, SYN. So now you know how Nmap actually works by default. By default, if you don't feed in any flags, okay, it's the TCP sync scan. TCP sync scan is the most popular and default option for very good reason. It can perform quickly, scanning thousands of ports per second on a fast network, not hampered by a restricted firewall. And so this technique is also open. This default technique is also known as half open scanning because you don't do the full TCP connection. You send a sync packet as if you are going to open up a real connection and then wait for a response. A sync ACK means that the port is open while a reset is indicative of non-listener. Get out of here. Okay? If no response is received after several transmissions, the port is marked as filtered. Okay? So now you know how Nmap actually works. And if you want me to prove this to you, sure. I'll just do that. I'll just run a Wireshark. I'll just run a sniff. I'll just filter by IP.addr by IP address as 3.12.160.152. Nothing. So this Wireshark screen is now only going to show scans that are have either the source or the packets at a source or destination 3.12.160.152. So I'm going to do this again. So watch this when I just fire up the regular Nmap scan. Nmap space 3.12.160.152. Bang. You can see what's happening under the hood. You can see all the a lot of TCP sync. You can see the resets being sent back as well. So yeah, Nmap is just going to look at all the different port numbers. And will ultimately get back a number. Yeah, get back results. But like, it's looking for all, like a whole load of port numbers. And now we're done. I'm actually going to do you know what I'm going to do? I am going to stop the recording of this, Wireshark, and I'm just going to do a save as. Oh, shoot. Can I do an export? Export specified packets. Displayed. I'm going to save this onto my desktop called default. I'm just going to call it Nmap. I'm going to save it as a PNG. I'm going to save this. Oh, let me go to my damn desktop. Bro. There you go. So now I'm going to open up, continue without saving. Here you go. So you can see, this is the Nmap scan that we just did. Port 80, port 443. 443 sends an RST. Get the hell out of here. There's nothing at 443. Okay, so 443 is closed. 80 sent back a SyncAC. That means SyncAC is that means the SyncAC at 8. Port 80 is alive. Port 22 is a port 22 gets an act. Ew. Okay, port 22 gets a SyncAC. It's like, what? Why does SyncAC? Huh, I don't know why. There's 3,000. What's the 3,080? Here you go. $5,900. Oh, here we go. Port 3000 sent back a SyncAC. Weird. Sent back a SyncAC, so that means that's up and running. So now you see port equals 443. 443 should have been a reset. Yeah. Why is it sending a whole shitload of like RSTs back? The target, it doesn't. That's weird. Did I just? Okay, I think I might just captured like way too many packets or something. Like, when did I? I'll have to do this one out again. Anyway, so okay. So now, what if we actually want to? We got open ports done. This is fine. But what about operating system, device type, software version being run? Can we do all three of them? Yeah, we can. So, what was it when cyber.trina? You use what, minus T4? Or you use lower T4, lowercase T4? Or uppercase T4? You did minus VV for verbose mode, and minus capital A for much more info. So here it is. This is another thing. Okay, you use upper. Yeah, that's what I figured. I mean, I've never seen lowercase. So here's another Nmap scan that actually uses not one but two flags. Minus the option is capital A and capital T4. Minus capital A is to enable operating system and version detection, script scanning, and traceroute. Minus capital T4 for faster execution, and then a host name. Let's do that out. So I'm going to clear the screen here. I'm going to show Nmap minus capital A minus capital T4, 192.168 and 1.18. I'm going to clear the screen here, and I'm going to do Nmap minus capital A minus capital T4. You can even do T5, 3.12.160.152. You're going to get a lot more detailed result. Now this time, yeah, those little things matter. I was like, I've never seen lowercase T4 before. I've only seen capital T. Oh, shit. Nope, still going. Oh, no, we're done. Oh, here we go. Here we go. Minus capital A minus capital T4. It only took 15 seconds. 15.8 seconds, which is really nice. So now, thanks to cyber.katrina, yeah, thanks. Yeah, minus capital T4 really does speed things a hell of a. I don't know why this should speed up, please. This one really sped up. Only 15 seconds. But now you see a lot more details, this is really fucking cool because now you not only see the port, the state, and the service, but you see the version, the software version as well. Port 22 is open, uses SSH, and the SSH software that's being used is whatever is the latest version on Debian 7, SSH 10.2. Port 5000, look at this. It identified port 5000 as open, is HTTP. It's officially HTTP. It is a unicorn web server. The HTTP title is a market news. And the operating system, Linux. The operating system is Linux. How confident it is? Pretty damn high. So a lot of times it's almost dead accurate. Oh, we also got results back. This one took 59 seconds. I don't know why. Maybe two. The only reason why I think it took 59.4 seconds and not that other time that we had is this is a public IP, so probably a lot of people are banging away at it right now. So 3.12.160.152. 20 port 22 is SSH. Also uses OpenSSH 10.0 P2 Debian 7. Port 80 is uses Nginx web server. The HTTP to web page title is Hitman. Port 443 does not exist. Port 3000 uses Node.js Express middleware. And the operating system is also Linux. Yeah, so we just did that. Boink! Yeah, we did some packets today. Software that's being run, yeah, we did that as well. All right. So we've answered some of the big questions. Open ports, operating system, location you can get by way of you can do location by way of who is. We'll get to that one next if we have some time. Device type, yeah, we can get device type as well. Login info, we'll do that. Webcam administrators, we'll get that next week. Before I don't want to get kicked off of Twitch, and the target is even up and running. So yeah, the T4, the Nmap scan. This is one usually my go-to is capital minus capital A space minus capital T4 and then the IP address. Yeah, so you can see a lot more detailed results here. It's nice. This is really, really the nice one. So one of the things now that I think you have seen is well, you can do a lot with Nmap. You can do a lot with Nmap. But yep, there's so many different options. Even if you do if you clear the screen and you just run Nmap with no IP, you get a lot of flags. You got a lot of stuff here. But okay, where the hell am I going with this? Well, here's the one thing. Here's the problem. The problem is that if you're using Nmap, the default scans, you can be detected. You can be detected. Why is that? Well, because, TCP sync scan, if someone's recording packets like I did here, you can get the source, you can get the IP address, you can get who's scanning. So, let's talk about ways to, well, is there a way that you can be a little bit more stealthy? Under the radar. And the answer is yes, you can. I want to introduce you to 3 types of scans that are a little bit stealthy. And in the document and in the manual for Nmap port scanning, there is these types of scans, and actually I just showed it right here. TCP null, fin, and Christmas tree scans. What the hell are they? These scans were designed to be stealthy, weird, under the radar. Okay, these 3 types of scans exploit a subtle loophole in the TCP request for comments to differentiate between open and closed ports. You all know right now that if you receive an RST back as a packet, let's say right here, this RST at 443 is saying, get out of here. There's nothing here. Go away. Alright, but in RFC 793, which is the governing document of how TCP works, the Transmission Control Protocol, written in 1981, it wrote, if the destination port state is closed, an incoming segment not containing an RST causes an RST to be sent in response. But then the next page just says, packet sent to an open port without the sync RST or ACK bit, so no handshake, bit saying you are unlikely to get here, but if you do, drop the connection and return. So, which is interesting. So, we can actually exploit this loophole in that why not we send a packet not containing either ACK, RST, or SYN, so no handshake bit. If you get an RST, port is closed. If you don't get a response at all, if the port is open, if the port is open. And this is think of it as the key advantage to the null, fin, and Christmas tree scan types is that they can sneak through certain non-stateful firewalls and packet filtering routers. And of course, another advantage of these scan types is that they are a little bit more stealthy than even a TCP sync scan. That's what it says. So how you do one out? So this one I don't think works on the AWS server. So how you do this is you have to use sudo nmap minus lowercase s capital N 192.168.1.18. I'm just going to fire Wireshark again, but this time I am going to just filter out ip.addr equals 192.168.1.18. Alright, I'm going to show you how it works under the hood. This is a no scan. You have to use sudo. 22 and 5000. But let's take a look at how things look under the hood. My computer at 192.168.1.219 sends a TCP packet with no flags. And you get back a whole bunch of RST resets for all the closed ports. Did it send out to 22? And see 22. You don't get an RST back for 22. So it means presumably 22 is open. 80? Get out of here. 443? Get out of here. 5000? That's why you see these as well. It says open/filtered. Okay? So, let's do this again. Let's record. Continue without saving. Now I'm going to show you, instead of a no scan, what about a fin scan. And you'll notice that all the packets start with a fin. And you get the same similar results. It doesn't work well. It takes it's a nightmare to work with on the AWS server. So you can see every single packet, you can see it start with a fin. RST, get out of here. Fin, whole bunch of fin packets. Alright. Just set the fin flag. And my favorite is the Christmas tree scan. The Christmas tree scan. Fin, push, urge flags. Light the packet up like a Christmas tree. Check this out. Without saving. Christmas tree scan. Bing! You can see all the flags on the packets. You can see every single packet flag start with fin, push, urge, fin, push, urge, fin, push, urge, fin, push, urge. Same idea. Yeah, it's not really stealthy. It's it just looks weird. And if it looks weird, then you can just, hey, something terribly wrong. Yeah, I agree. So, we did the default Nmap scan. We did stealthy scans. Let's see what we did today. Kill chain, information. We did kill chain. We did ping. Ping you can't ping a port. We did Netcat. We did Nmap. We did the default Nmap scan, and we also did a few stealthy scans as well. Next week, I'm going to show you one more Nmap scan that really help you to not get caught. The caveat is, you can do it wrong. But we get 5 minutes. And I want to leave the close today with one more reconnaissance tool. I want to show you one more reconnaissance tool. And that is a tool that you can get a lot even more crazy stuff, including webcam and pics, connected devices, and even desktops. I'm only going to introduce you to this tool on Twitch. I don't feel comfortable with running this tool on a live audience on Twitch because I don't want to get banned. Now, one of the things about going to computer security conferences and meetups is, people. People can tell you some really cool shit. Now, each and every year when I go to DEF CON, I meet up with friends who I haven't seen in person for a full year, and and usually the conversation is dude, you hear about this new tool called, X, Y, and Z? Now, back then there was no Discord, but that was what it's like back in 2008. And I remembered in 2008, I had a friend, Michael Montesillo. He's now at Oracle. Michael, I want to give you a shout out. Yeah, I heard from Tufts that you sent me his you sent warm regards. So Mike and we were young bucks back in 2008. We were young bucks. We were bottom to rung people. And we met up and we were playing the amateur capture the flag. I think it was amateur capture the flag when we met up in the table. It's dude, there's this new tool called Shodan. This is so cool. It's a search engine. You can find all the shit that's connected on the internet. I was okay. Go to Shodan.io. Shodan.io. And this is now, Shodan is like your friend. It's now a friend for many people doing any sort of intelligence work and any sort of intelligence work. It's also referenced quite a bit in news and white papers. So what Shodan is think of it like a search engine for all the shit that's connected to the internet. that includes like baby monitors, dishwashers, crematoriums, distilleries, power plants, wind turbines, like all those and also SCADA systems. So Shodan is wonderful to see like all the exposed shit on the network. Now, if you have an educational .edu account, you can get like a free account. So unfortunately, back in the days, I had to pay $50 for mine. It was a $50 one-time fee. It was on a Black Friday. But Shodan is wonderful because you can type something in like, for example, like MongoDB, and you can find all the MongoDB. Oh shit, this works! MongoDB, and you can see all the MongoDBs exposed to exposed in the world. Here, port is 27017, 98,677 MongoDBs exposed in the world. Most of them are in China, followed by the United States. What you see next is like all of the IP addresses that actually are hosting the MongoDB. You can click on the IP address, and now you can drill down and see that this IP address at 51.77.192.1.37 have the following open ports and more detail. Also, what's crazy is you can see that Shodan has identified that this target at 50 on the server at 51.77.192.37 has a whole bunch of vulnerabilities. Now, how does Nmap how does Shodan work under the hood? Think of it this way. You learned the Nmap today, but what it is, how Shodan works is they have basically think of it this way. They run an Nmap scan of the entire internet every day. And you don't have to run that Nmap scan. They already did the work. Shodan already did the work. This one has 3306 actually open. What the hell? You can even see this is in France and the city. What? Really? Yep. Can you actually go and access like if you click on this, if you click on, let's say 80, for example, you can actually, this little icon right here, you can actually go directly to site. I'm not going to do it. You do it. But what is the, guys, what is the port number for Minecraft? Oh, man, what's the Minecraft server? I should know this. You can go to Explore. Actually, you can go to Explore. You can go to Video Games. And you can explore all the open Minecraft servers in the world. Yeah, 25565. Here you go. Oh, you have to log in to use the search filter. So 25565. We can do that. 221. How do they find the IPs to it just hammers all the IP addresses in the IPv4 space. Yeah, and so if you want to get like really specific searches, you got to log in. Yeah, one thing as cyber.trina said, please don't try to hack stuff on Shodan. Like, please don't. Like, don't do that. Cyber.trina, let's save that conversation for another day. What the hell? Like, honeypots, So Shodan can actually do search things like industrial, you can search for industrial control systems. Like power plants, wind turbines, databases. Oh, yeah, explore. I can do TCP 3306. Nah, I have to log in. So, yeah, in this case, this is a good place this time, please log in to use the search filter. I'm not going to do that now. I'll do that on Tuesday. And, let's say you're in for a ride. Yeah, in cyber.trina, you know that you can be in for a ride when you use Shodan. So, thank you, everyone. And next week, we're going to learn, well, What is it? How to take down the internet? Don't try this at home? Yeah. Distributed denial of service attacks. Take care, everyone. Yeah, you have everything to do. Yeah, I think we covered everything, and you have everything necessary to do lab number 3. Yeah, you have everything to do. You have everything now. All the tools and techniques to do lab number 3. Take care, everyone. And thanks to Cyber.Trina for being the special guest today. Yes, thanks. Thank you. Thanks all. Yeah, that works. I think I know Cyber.Trina. Oh,